Yeah, I thank you for reminding me. Okay?
Are we going to use any of that stuff?
I will talk about this in a bit. Okay? For the most part, like you guys are not touching this today, unfortunately. But I have it here so that I'm going to be showing you some of this stuff later on.
Can we touch it?
What are you doing?
Hey guys, let me get through the instruction. You will find from Mrs. Lisa the first few minutes of class, and it's probably true for most teachers. If you allow us to get through the instructions, we answer most of your immediate questions. We really do. And interrupting us just slows that down. So this is the last of the material from chapter 2. Okay, where we're looking at metals and non-metals. They're kind of seen as like, in some ways, opposites on the periodic table. You'll find metals take up, a good majority at the left side of the periodic table. You have the non-metals kind of in that right top corner, and then there's the stuff that was kind of in between. But I want to talk about those last two sections in chapter 2 because when we come back next week, it's pretty much review, then test. Okay, we're going to be having a test again on Wednesday.
Will we be doing a Kahoot to review?
No. Okay. Honestly, I don't tend to do Kahoots. We'll see what kind of review we're going to do. I haven't quite decided yet. Okay, that'll be up by Monday. But we are wrapping this up so that we can move on to more interesting things. Okay? Well, it's interesting as we can move forward and we start going, well, how do these things interact with each other? Because no matter what, this in and of itself is just kind of a lump and doesn't really do anything for us. We're like, yeah, cool stuff. But when you actually get to see these things and understand how they're interacting with one another when we try to combine them, that's the fun stuff. Okay? So I'd rather make sure that we have more time to do that rather than, as I could probably teach about the periodic table for the rest of the year and still teach you stuff, but we don't want to do that. That would be kind of boring to sit there for that long learning all those details when you don't need that yet. Okay? So test next Wednesday. You have no more Cornell notes until after the test. Okay, when we start looking at chapter 3, which is all about how these different elements bond together. Okay? What I do want to look at today is I have a video. I'm going to show the video, and your homework will be to basically pick out from the video everything that they say about metals, and I'm talking their properties. What's a property? What does it mean when I say a property of an element?
Characteristic of it?
A characteristic? That's a good word. Is there any other words that we could use? Well, we can't really use property to define property.
Oh. Where it first started is?
No, because it is what it is. Like, it's not really, that is its starting form. How about a quality? Like you say whether something's shiny or not.
Oh, like quantitative, qualitative.
Yeah, kind of like your quantitative and qualitative. I can use quantitative and qualitative ways to describe any of these elements. And I'm going to be describing different features about a particular element or type of element. So I need to look for those features that seem to be true for all metals, for non-metals, and for metalloids. Okay? So I'm going to show you the video. Now, you'll find that in Google Classroom. Now, here's something that I need to point out to all of you. Okay? Because some people may not have really realized everything for your week is always going to be here in classwork under that week. Sometimes things are assigned that don't have a due date, right? There's just, hey, take a look at this. But there's not necessarily a due date other than I need to look at it for that week. There are some students out there, I'm finding recently, that they just go to the stream and the only thing that they're doing is they're paying attention to what's in the to-do list and nothing else. They look over here and until it's like the day that it's due or it's like happening tomorrow, like they miss it. And it feels like, you know, the teacher's telling you at the last minute, oh, this, and no. This we don't really have control over. This is Google just showing you, hey, you needed to get that in. But if we go to Google Classroom, and that's where we should be looking for all of our work, you'll find week by week, hey, here's everything that you need to know and look at for the week. So I'm going to be posting announcements for tests, and I still need to do that to let people know at home that, hey, we have a test next Wednesday. Because maybe they're not watching the video, and I don't necessarily assign watch the video. I don't think everyone needs to watch the video, but some of us do. Okay, so this is always your go-to to look for, hey, where are things? So this video, the questions, where I ask you to make this list is really due for tomorrow. And here's what the doc looks like. It's this simple. There's this little chart that says, hey, give me the properties that they told you about for metals, for non-metals, and for metalloids. Now, I thought this was kind of a cool video because this was not the usual science video, because this was talking all about, hey, what are the metals, the non-metals, and the metalloids that are used inside of your phone? Have you ever been curious as to what's inside of one of these?
No.
No?
I know it's a bad.
Well, you're going to learn a whole lot about it. Okay, so the video's linked. We're going to be looking at it right now. I need to make sure that we have some sound plugged in. No.
Have you ever stopped to think about how amazing your smartphone is? It has more computing power than the system NASA used to put humans on the moon. 50 years ago, no one could have imagined that you would be able to browse the web, listen to your favorite bands,
So I would
and
just
connect with your
watch the
friends
video.
using a
That's
single
just it
object
right
that
now.
fits in the palm of your hand. None of this would be possible without chemistry. About 91 of the 118 elements are metals. Around 20 are used to build your phone. Most metals share distinct physical properties that make them ideal for manufacturing smartphones. Metals have luster, which means they reflect light. Smartphone designers use this property to market smartphones as a sleek and modern piece of technology. Metals form strong crystalline structures, which contributes to durability. If you accidentally dropped your phone, the metal shell wouldn't break, but you may have to live with a cracked screen. Unlike glass, metals are malleable, which means they can be hammered or pressed permanently out of shape without breaking or cracking. Your smartphone can distinguish between a tap, scroll, or zoom because of metal's ability to conduct electricity so well. Modern smartphones utilize capacitive touchscreens. The screen contains a sheet of glass with thin lines of a highly conductive metal compound arranged in a grid pattern. At each intersection, an electrostatic field is generated and registered as neutral. When you touch the screen, a tiny bit of electrical charge enters your finger, which disrupts the field and produces a signal. Metals are ductile, meaning they can be pulled into wires. Whenever you interact with your phone, a signal is transmitted through a complex highway of wires to your processor. Your processor is like the brain of your smartphone. Similar to the human brain, it receives signals from different parts of your phone and translates them into instructions for action, like opening YouTube so you can watch the latest video of baby goats in pajamas. Like metals, metalloids have luster, but unlike metals, they're not malleable or ductile, so they break apart easily. Metalloids are a crucial component of your processor because they're semiconductors, meaning they conduct electricity, but not quite as well as metals. Semiconductors allow electricity to pass through your phone's transistors in a controlled manner. If you used metal, too many of your transistors would activate, causing your processor to malfunction. The properties of nonmetals are the opposite of metals. They're brittle solids or gaseous at room temperature, and they're not malleable, conductive, or ductile. Their specific properties are so diverse, they don't have widespread applications like metals. One application is responsible for powering up your phone. In a battery, there's a positive electrode, usually made of a lithium compound, and a negative electrode, usually made of carbon, a nonmetal. When the battery is charging, the positive electrode gives up some of its lithium ions, which move through to the negative electrode. When the battery is being used, the lithium ions travel back to the positive electrode, producing the energy needed to do things like map directions to a new restaurant in town. By utilizing the general properties of metals, metalloids, and nonmetals, we can continue to create incredible advancements in technology. Next time you text your friend about meeting up for pizza, take a moment to appreciate the complex chemistry responsible for making it happen. We wouldn't be able to create these videos without your support. If you like what you see, like and subscribe to our channel. If you
Okay, so let me back out of that just a little bit. What was kind of interesting out of that video? Did you know that the glass for your screen actually has metal embedded inside of it, like really super thin?
Not metal.
Like I didn't know that. Okay, I knew that it had to do with the electricity and that charge that we even have ourselves, and so like if you're wearing gloves, like only special gloves are able to you're still able to use your phone, otherwise you can't. But that was just like, wow, you don't really realize. Like I knew that metalloids were used inside of there to control the flow of electricity and whenever we're using electronics. But 20 different metals? It doesn't look like there's 20 different metals. It all seems like maybe one. How do you think they used 20?
They made it smaller.
What do you mean they made it smaller?
Like they, maybe they just, got a little metal.
Do you think all 20 are mixed together?
No,
No?
they're put in different places.
So we might have 20 different places. Is it possible that some of the 20 are mixed together? Yes. Do you know what it's called when we mix metals together?
It started with D, I think.
It starts with an A, at least the one I'm thinking of. When we mix metals together, they're known as an alloy. A-L-L-O-Y. Okay, so I can mix different metals together, and why we do that is because we want to take some of the properties of each of those metals and combine them for something that works better for our purpose. Okay? It's like how different metals were made through the ages. When we talk about Iron Age, Bronze Age, then they learned how to make steel. It's because that they were combining new things with those metals in order to make them stronger or lighter. Okay? So what I want you to do is I want you to pull up from Google Classroom specifically where that video is, this list of properties that were given in the video. Okay? Because I want you guys to have these properties on your screen as we start to look at these. Okay, so everyone should pull this up from the Google Classroom. Everyone gets their own copy. Okay? And then we'll fill it in together. Is there anyone that doesn't have this up yet? Everyone has this on their screens? Okay? You know, like yesterday, I asked everyone, on a call, I'm like, do you have your test? They're like, yeah. I'm like, thumbs up? You have it? Yeah, I can see it. 5 minutes later, where's the test? That's why I check. It's nothing personal, it's just, I never know whether, people are listening. So, there were some certain spots that definitely made this easier, right? Let's see if we can find those. Oh, right there. What does luster mean?
Shininess?
Shininess. There's light glinting back off of it.
Sure.
Okay, and so you might want to put, what these words mean in your own words too. So you need to understand what these mean. You're like, oh yeah, metals have luster, they're malleable, they're solid, conductive, ductile. What's ductile? Oh, I don't know, I just know they are. Like, it's one thing to be able to, give the answer. It's another thing to be able to use it, explain it. Okay, so luster is shininess. Malleable. What does it mean that something is malleable? I have some.
Bendable?
That is able to it can be rolled into a flat sheet, flexible.
Yes, it can be made into a flat sheet. It's bendable, it's flexible. All of those are true. I can pound it and it's just going to spread out. And therefore I can bend and shape it however I want. Solid. I don't think we have to explain solid, do we?
Just in case.
I could probably come up with some pretty rude examples for that one. I don't know.
Concrete.
Huh?
You say concrete?
Concrete is
always-
Yeah, but then turn out to be solid.
Okay, at any rate, solid means it has a constant form that doesn't change, right? It's not flowing anywhere, doesn't flow. Conductive, what does conductive mean?
It combines a lot of electricity.
Okay, it allows the flow of electricity, it doesn't really combine with the electricity, but it will allow the flow of electricity and it will allow the flow of heat. So metals heat up, metals will allow electricity to pass through. So it's conductive, where it allows a passage or flow of electricity and of heat. How about ductile?
It's able to it can be pulled into long lines of your
Yeah, so ductile, rather than squishing, you're doing the opposite. Stretch. So honestly, that's kind of a way to remember it. It's okay, malleable. You kind of think like Play-Doh, you're trying to form it. And then ductile's I'm gonna pull it out.
So
Like rubber.
Yeah, we can make thinner and thinner spaghetti.
Wait, how can metal be
Because it can.
when it's
It-
heated?
Yeah, typically, okay. That's a great question. Bella's like, well, how can I do that? I can't take a penny and go, "Rrrr." You're gonna be there for a while. But if you apply some heat, it goes, oh yeah, I can do this.
So I can make it.
What? We're not melting it entirely, we're just allowing it a little bit more freedom of movement. Okay? But if I had enough strength, if I have the right machine, it doesn't matter what temperature things are at, we would be able to pull it apart.
I suppose
Stretch, STRETCH. Not a problem. Okay, so these other ones are kind of similar, but we saw the not symbol, right? So let's continue on to the next one. Yeah, the pajamas was kind of weird. Haha, metalloids.
Some of them, some of the properties, are the same as ones.
Some of them are. I agree. Really, there's only one that's the same. And one that's kind of the same. So, once again, they're shiny. But they don't seem to be shiny in the exact same way. Like, they don't look like you'd expect a metal to look.
It's like reflective.
Yeah, it's a little reflective, but yet it still looks like it's kind of a non-metal. Does that make sense? So, like, they're shiny, but you're gonna notice it's not quite right. These are not malleable, not ductile. I can't bend it and reshape it and pull it into strings, none of that. Okay? They're a little bit more like non-metals that way. It's just like, no, you can't do that. Notice they also said they're not durable, so they're not actually terribly strong. They're kind of weak in a way. And semiconductive, what does semi mean? Kind of, half, part way, like semicircle, not entirely. So they're conductive at times, but not always. It depends upon conditions. And they use this inside of the electronics because, hey, this makes it easier for it to control the flow of electricity. Metals allow too much flow, like it's just like, woo! You know, we flip on a light. We flip on a light, everything's instantaneous because the electrons go racing through to power everything. We don't need that in our devices, otherwise everything gets overheated. Awfully fast, causes problems. We want to go nice, slow, steady flow. So we have to use these metalloid semiconductors. Okay? So, anyone ever heard of Silicon Valley?
Yeah, kind of.
No.
Where is Silicon Valley?
I have no idea.
Never heard that phrase?
I mean, I've heard.
Okay, you guys know Microsoft, right?
Yes.
Yeah.
Okay. At a loss as to, some other possibilities for different computing companies. But Silicon Valley is the home of a lot of electronics and computing companies in California. Why do you think they call it Silicon Valley? It's not necessarily just silicon, but that was probably the start.
Oh.
And they don't actually have silicon there.
Maybe they have a lot of these metals in order to make phones and computer devices.
Really, it has nothing to do with Silicon Valley itself is not a source of the metal. Like, they have to mine the semiconductors elsewhere. Silicon is one of the semiconductors. Okay, it was one of the first ones that they used for these chips that we have in our devices now. But the reason why they call that area of California Silicon Valley is because that's just the home to all of these computing and electronic companies.
Oh.
That's kind of like a hub. Like Houston is known for oil, right?
Yes.
We're known for oil, we're known for the medical fields. Okay, we have the medical center and we have the oil industry as being two of our main industries. In that part of California, it's all about semiconductors and making use of those semiconductors. Even though that's not like, we don't have a ton of oil right in Houston, but we're still the heart of that industry. They don't have a ton of metalloids all sitting in Southern California, but that's still what they're known for. You have something to add?
Yeah, so you know how like a couple of years ago there was like a new Samsung or whatever,
Mm-hmm.
and it was like blowing up in
Mhm.
people's like homes. Why did it do that if it had like all these things that would help?
I would assume that, and I don't know for sure, I'd have to like look it up because I don't remember, looking it up really at that time. Some of these phones or some of our electronics period, the same thing can happen for different laptops and computers, okay? It has to do with the battery itself, how the battery was designed and how it's interacting with the device. And, we can have problems with batteries in our vehicles, we can have problems with batteries here. And if something isn't connecting in the expected way, it's causing a problem. That's what's causing an explosion because there's a lot of energy being released.
Question. So you know how when you leave your phone out in the sun for
Mhm.
a long period of time,
And then once it stops working,
it doesn't work?
yeah,
Why do you think that happens? Is it because it gets overheated?
yeah. Honestly, things when they get overheated, electronics stop working. It's just like a fail safe to go, oh no, sorry, can't right now. Just wait until I cool down. Like it's like I have too much of a temper. In certain neighborhoods, like there's the different, telephone and internet lines going through the neighborhoods. And you'll see at some particular junction boxes, like there'll be like an AT&T van or a Comcast van and so on. And sometimes they put these really big tanks of gas and they hook it up to these lines because some of the older neighborhoods need those lines to be cooled. And so they use things like nitrogen to cool down the electronics there to make sure that things aren't overheating and that we don't have problems with our service. Electronics like to be just the right temperature. It's kind of like, Goldilocks and Three Bears. We don't want it too hot, we don't want it too cold. We're trying to control the conductivity of things so that we can get it just right. Okay? You find that even with your own, regular devices every day. Here's the nonmetals. Brittle solid. Gaseous. Does that mean it farts a lot?
Yeah.
No? Okay, just making sure you didn't think that. What does it mean to be brittle?
Easily made?
Easily breakable. So they seem pretty solid, but I can easily like crumble it. Okay? Gaseous. What does that mean? How can something be solid and gaseous?
No.
Do you think something could be solid and gaseous?
Yes.
I think when you see, because it's easy to break, maybe when you know how so
Okay, I see where you're going on that. She's like, since they're brittle and easy to break, maybe they break up so small that they could become a gas. Some of these things at room temperature are gases. Some of these things at room temperature are solids. If I increase temperature higher than room temperature, way higher than room temperature, some of these solids will turn into gases. If I reduce the temperature way down below room temperature, some of those gases become solids. How, the state that it's in between solid, liquid, gas all has to do with how much energy it has. And so each of these has a different melting point. Okay? Every single substance has a melting point. There's every single element up here, I can make it a solid, a liquid, or a gas, depending on the temperature. It's just most metals, okay, the temperatures can vary wildly and they're going to conduct all that heat very quickly, that the change is going to happen more rapidly. than some of the things that are happening over here. So when they say that they're brittle solid or that they're gaseous, they're not meaning at the same time, for the same thing. This is saying, hey, at room temperature, in regular normal conditions, some of our nonmetals are this, some of our nonmetals are this. Okay? Right now we're breathing gaseous nonmetals.
What?
We need to breathe the gaseous nonmetals. Oxygen, nitrogen. We need to breathe our atmosphere, right?
Yeah.
They're nonmetals. But there's other nonmetals that we don't necessarily breathe in, especially if they're solid. That causes problems.
So when you touch salt, whatever, the yellow pumpkin, when you touch it, it turns into some kind of powder. Is that technically a gas or?
No, it's only a gas when really the individual atoms are spread out. It's a good question. Bella's asking kind of like, can I take that brittle solid and break it up enough that I have these like teeny tiny pieces? So small that if I threw it into the air, would it be a gas? Like pixie dust? No. Because even though those pieces are really small, they're not like atom size small. And a gas needs to be atoms that refuse to touch each other in comparison. Does that make sense? Good questions, though.
Maybe use the restroom.
You're gonna miss some stuff, but yeah, sure. Come back quick. Come back quick. So, not malleable, not conductive, not ductile. They're just, they're there. But you know what? They're really important. Okay? Those nonmetals are really important because they allow us to breathe. Those nonmetals are the majority of what make up our bodies. All that carbon, oxygen, hydrogen. That's building blocks of life. Okay, so there's not many, and they're not conducting things, but they're what make you you. So, let's take a look at some of these. And I told Mrs. Gross, I'd love to show them one thing in particular, and we might just have to wait as we look at bonding or reactions or something. Okay? Because I really can't get into showing you guys this completely. I just want you to have a sense of what some of these things look like. Okay. So this here, I'm gonna walk around like this. It looks like there's kitty litter in there. Okay? There's like kitty litter inside the seal, like what looks like a paint can. And inside of that, there's a bag that has a bottle. This is like Fort Knox, right? Kind of, almost. Okay? I don't know if this is showing. Okay? Yep, for those at home. Kind of a little bit like Fort Knox. Now, and I'm not going to show you what you want to see, unfortunately. So I'm trying to get rid of my kitty litter here. Okay, so now I'm going to release the hand, right? So inside of this is another bottle.
Oh wow. A bottle.
And I open up this bottle, and there's some inside of it isn't water, it's mineral oil. Okay, mineral oil is just like a type of oil that we wouldn't use for cooking. It just seals this off from any air or water.
Oh, wait.
Ooh, she has some ideas.
Oh, it has a water preservative.
Okay? So, it looks really nondescript. It kind of looks like maybe a piece of cheese,
Yeah, it does.
maybe like a chunk of eraser. This is actually kind of, I don't know, this is kind of like an eraser. That is sodium. It reacts with the water and the air rather strongly. That's one of those alkali metals.
What if someone ate it? What would happen?
That would be very bad. I would call poison control.